Okay, so let's get rolling. I don't remember where we left off last time, but it looks like I put a error in my player controller to remind me. All right, so we are continuing to go through, I guess the tutorial that I had you guys do over the weekend to add some color commentary over some of the stuff that you did. Um, Otherwise, there was probably a lot of cut and pasting and banging on stuff till Unity stopped screaming, that kind of thing. I promise once you get into Unity, it's actually pretty easy to work with, and um, it'll be a lot easier for you to work with as we move forward. But I do recognize that initially, as you're getting your development environment set up, things can be quirky. Good.
I hear about like Unreal, like the Unreal game engine. Is it
Mhm.
like similar to Unity?
Yeah, very, very similar. So for online folks, the question was about the Unreal game engine. So years and years and years ago, there was a game that had their own custom game engine called Unreal. Years later, they made it public. Um, Back in the day, it was considered a high performance game engine, and back then it was common for companies to have uh, a lot of proprietary stuff. It became available in the early days. I would say it was not very easy to work with because ultimately it had started off as an internal tool. Um, Unity came out around the same time, probably a little bit later than on, actually, maybe it was the other way around. But regardless, the two tools to your question are basically the same. Whoever has come out with the latest release likely has something they're bragging about that it does that the other one doesn't. The main reason we use Unity in here, um, uh, at least from a historical perspective, Unity is a lot easier to learn, even though both tools effectively function the same way. Unreal just was a little bit less polished because of the nature of what it was. I would say that's not necessarily the case today. They're probably reasonable to call them equivalent tools, and depending on the exact type of game you're doing or something like that, Unity might be better at certain things, Unreal might be better at other things, so maybe you'd make the decision there. From a student perspective, I think Unity has far more documentation, far more examples. You can find tutorial videos, things like that. So if you're trying to learn something, you probably have more resources available to you for Unity stuff. But I promise you, your knowledge of Unity would let you go and pick up Unreal pretty quickly. Same thing's true for mobile app development. You know, if you're getting into iPhone development versus Android development, they both kind of work the same way. They both handle MVC in their own little way, but it's very similar and things like that. So getting knowledge of one basically means you might have a rough weekend teaching yourself the other one, but then you're right up to speed with it. Apparently, there is a couple of former students have reached out to me about a game engine that is gaining some traction. I have not worked with it, and what's the name of it? Godot, yeah. I haven't worked with it. Apparently, it's getting popular. Maybe I'll look at it in the future. Probably a very similar argument, at least for right this exact moment, related to examples and documentation, that kind of stuff. But I think the main concern sometimes is that because these modern game engines like Unity and Unreal, which I would make the assumption both of them are more powerful game engines than Godot might be right today. The issue is that sometimes Unity is a little sluggish if you don't have the greatest hardware or something like that. And traditionally, students might not be running around with $5,000 laptops, all that jazz. So, it's the nature of the beast. I have to kind of decide yeah, what's the point of what do I make you install versus, I mean, I don't like online GDB either, but it's convenient that I don't have to deal with a zillion people's installs. So kind of is what it is. But I think having the skill of Unity would directly relate to Godot as well. Um, I doubt there's a significant difference in how they do most of the stuff. So in any case, if it's sluggish on your computer, I'm sorry. I understand. We do have the lab down the hall here, the esports lab that you could put Unity on those machines. It's probably even already on some of those machines because students have done it in the past. They should be able to run Unity just fine. Huh? Yeah. The in the lab down the hall, the PCs for that esports uses. That's a shared lab. So during the day, as long as the machines are open and people aren't gaming on it or whatever, especially in the evening, um, feel free to go use those for your homework, whatever. I bought the computers, so you can use them. um, they're probably getting a little bit old for esports too. I'm guessing for some of the newer games, the GPUs in I think are like 1650s Nvidias. Okay, yeah, but in any case, I'm sure it would run Unity just fine. Um, so it is what it is. Okay, so let's pick up where we left off last time. I'm guessing I'm not going to quite get to a point where I can give you an assignment over the weekend, so I'm going to try not necessarily to rush. Well, I mean, at the end of the day, it's your loss because that's just less experience that you're getting. So I would maybe encourage you to kind of try to enhance the game for your own knowledge over the weekend or something. But I'm going to not necessarily rush through this so I can make sure I hit these highlight reels. So last time we were talking about the idea of colliders, where we if we kind of go back into Unity here and we click on one of our game objects. And we remember that all game objects in their most simple form is just a transform. Yet we can start hanging various components off of game objects that give them more and more abilities, that some of which we have to control, some of which the game engine does for us. One of these things that we can do is we can say, hey, I want game objects to be able to bang into other game objects through something called a collider. Now, if you want to have the game engine fully handle what happens related to a collision, you probably also want to have a rigid body on there. So gravity and mass kind of comes into play. Um, Otherwise, we can programmatically handle this. So let's see what slide I was making related to that. Um, all right, so we were talking about colliders. Kind of colliders come in two flavors, or at least our way of handling colliders come in two flavors. One is called a trigger. Trigger basically says, game engine, don't do anything on your side related to physics or mass or them banging into each other. Just let me handle it fully as a developer. And we handled that through a function called on trigger enter. So back here. And we can see two different examples here, right? So naming convention, one thing you're going to see a pattern of in really a lot of event-driven programming, where when something occurs, some function gets called. That's event-driven. An event happens. Somebody yells to something else that, hey, you got to take care of this. A lot of times those will start with the word on. So on trigger enter will get automatically called on this object, actually on all objects involved in the collision that have implemented this function. It will automatically get called when this happens, when a trigger is triggered. It'll pass us the collider of whoever we banged into. In this case, what we're doing is, because there's lots of things in our scene we might run into, this is something you got to be considerate of when you're writing your games. Um, for instance, we're probably constantly colliding with the ground. we maybe want to handle the ground differently than pickups and things like that. So that's where these if statements come in. Again, you're seeing stuff right from back at the beginning of 200, ask questions, repetition, remember stuff, right? So we're asking a question, what did we bump into? If we bumped into a pickup, I want to do something about that. If I didn't bump into a pickup, I'm just going to ignore it and do nothing. Okay, so this is how we handle triggers. Now, for collisions, normal collisions, a non-trigger based collision, you get to optionally handle it programmatically on top of the physics engine itself handling it. Okay, so if you want there to be a visual thing that's handled by the physics engine itself, you leave the trigger button turned off. So you make sure that this guy right here is not checked. That way it goes to on collision enter if you wrote it, as opposed to on trigger enter. So when you have that unchecked, this game object will have physics applied to it automatically based on what mass you have and the rigid body and all that, and the speed it's currently going, all that stuff. If you have trigger collected, you're basically saying don't do any of that. And I'll handle it all in code. But you can also handle normal collisions in code as well. So right here, we are asking the question, if we bumped into our enemy, so they had us create a tag as part of that tutorial where we went in and when we created our enemy, this guy right here, let's go find him over here. I think we did the body inside here. The enemy body, we tagged him with just the word enemy body. You could have called it whatever you wanted, but this guy has a collider on it. Notice our enemy body has a box collider, so he knows how to bump into other things. It's not a trigger, so when he bumps into things, physics happens. I'm not sure we had to have it like that. Actually, it's possible your collider does have to have trigger turned off on this because this guy is part of a nav mesh agent. I don't remember the exact rules with that, but nav mesh agent might require the physics engine to be involved in him bumping into stuff. You'll run into little idiosyncrasies like that. But if we're just thinking about the enemy body game object, he has a box collider, the trigger is turned off, so he's going to bump into stuff with physics involved. We can then optionally do something about that. We're handling it inside the player controller. So inside the player controller, on collision enter, which means we collided with something else that isn't a trigger. We get the person we collided with. We ask, was it an enemy body? Remember, right now we're coming at this from a player controller perspective. So every game object that has this script attached to it will get this function called. Right now we have one game object that has player controller attached to it. We only have one player, as opposed to, I think we have a script for our pickups too. I don't remember, but we'll go and look here in a second. There's many pickups on our scene. So if we did have, we do have a script. That's the thing that makes it rotate, right? So if we just quickly go and look at that and we click on our empty game object that we've used to just organize all our pickups, and we see that pickup has a script that we attach to it just called rotator. And that rotator script, pretty simple here. It is a mono behavior. For being a mono behavior, it says we will call the start function once for you to do any setup, and then we'll call the update function every frame, or potentially fixed update if you want to have it happens 60 frames a second. In this case, we didn't have any initialization to do, so we just didn't write the start function. So it called a start function that likely did nothing, similar to like when we built threads. The thread in Java, the thread class comes with a run method that does nothing. So if we want our threads to actually do stuff, we have to overwrite that. We have to write our own version of run. Same thing would be true here. Mono behaviors have a start function that doesn't do anything related to our stuff. So if we want to initialize something, we can. In this case, we had nothing to initialize, so we just deleted the start function. If you left it there, it wouldn't have been the end of the world. But what we said is, hey, every single frame, I want to rotate the game object that owns this particular rotator script. And again, I would probably say this dot transform dot rotate. I copied and pasted a lot of the stuff, so that's why I didn't have it on there. But we're saying whatever the game object that owns this script, which this guy in my code is hanging off of 8 different game objects. So I created 8 pickups. So each of those 8 game objects are individual instances of that game object. So there are 8 different versions of this rotator script running currently, and each one of them will have its update function called every single frame. Something to kind of think about when you're working with game programming. Frames per second happen often, right? Even if we used fixed update to limit it to 60 frames per second, that means 60 times every second we're doing this stuff across all your game objects. Okay, so if you start having too much stuff happening individually, you might start slowing your game down. That's where it becomes CPU intensive, because all these things have to happen every single frame, and if it takes longer than a frame for something to occur, you may not want it in update because that's going to cause issues. Go ahead.
So for bigger games, that's why they have to lower down the frames per second, because then, well, there's like I mean, for example, there's the Zelda game that, on the Switch, very big, but it had to be 30 frames per second. And a lot of people are, mad about that.
Yeah. Sure. So yeah, so the online folks, the question is that why some games lower their frames per second? I would say it can happen from either side. So for instance, we had, I don't remember which was in the player controller that we use fixed update. Yeah. So we decided on the programming side to limit our frames per second here to 60. So sometimes you can do it on the programmer side if you just know, like, look, this does not have to happen more than 60 times a second. Or you're trying to create kind of an equality thing across all people playing your games. So that might be one thing where they say, look, if I do 30 frames a second, like in the Zelda game you're referencing, maybe that allows us to feel confident, especially since you know the hardware you're targeting. The Switch is a set piece of hardware. We started separating from that a little bit with modern consoles where you have like PlayStation 5 and PlayStation 5 Pro and things like that. So it's not quite as cut and dry as it used to be, but if you know the exact hardware you're dealing with, you can kind of build your game to run well on that. So it's possible they decided, okay, well, 30 frames a second lets us do all the stuff we want to do. And if we fix it to that, then we're not putting any additional burden on our logic, as opposed to if we just left it wide open. It says, look, every single frame, call this code. I mean, the Nintendo Switch is not a crappy computer, right? It's not this, but it's capable. There's probably plenty of. It has the ability to run many things at more than 30 frames a second, including probably Zelda, right? But when you use update, it literally will call that function every single frame that particular computer could generate for that particular game, which might mean that it's getting called very often, which might then put more stress on it than it needs to be if you only needed 30 frames a second. So that's when the developer makes that decision. The flip side is when the developer says, I'm going to rate this game, and this becomes part of the industry, actually, if you get into game development. These big AAA games take a long time to write with huge teams of developers. Then you have kind of the small indie games where you might have 1, 2, 3, 5 developers, something like that. They don't take quite as long, or they just evolve over a decade. But for these large games, sometimes they take 3, 4, 5 years for them to make those games with huge teams of developers. So you imagine if we're starting a game today that we imagine is going to hit the the market in 5 years. We have to kind of guess what the average gamer's computer looks like in 5 years. So we might choose to use pretty, we might have stuff in our game that maybe won't run on computers all that great today unless you're running the latest, greatest, beefiest machine, whatever. So sometimes the programmer doesn't try to limit it. They're trying to guess what the games will be like, and they would just use normal update. And sometimes the gamer just needs to get a better GPU if they're doing PC gaming because they can't run that game. In fact, a lot of our PC gaming benchmarks that are out there are based on like some certain games that have kind of historically been known to be very GPU difficult on GPUs. A lot of times now, especially for VR stuff, VR puts a significant amount of stress on a GPU, much more than a 2D or flat panel type game, even though high resolution, high texture stuff also puts a lot of stress on your GPUs. But things don't have to be all that pretty for VR to put stress on your GPU. So it's easy to have tests for that. So it really can come from either side. I know it's a kind of a big answer, but it's a major part of game development. Um, so we were saying that every single one of our pickups has this rotator script attached to it, which in my game that means there's 8 instances of pickup, which means there's 8 versions of this rotator script, and every single frame, each of those 8 rotator scripts will rotate the transform of the game object associated with that particular pickup around some vector. So this is 15 on X, 30 on Y, 45 on Z. So it's just rotating around that kind of that line created on that. Then you have this time delta thing, and this is a big thing in game development. Anybody look into what time delta is? Delta time. No. Say it again.
It's like the change of time.
Since the last call to update. Yep. So you'll commonly find something like this, the time.delta time sitting inside of your update or your fixed update, those kind of things. What this does is it says how much time has passed since the last time I did this, since the last time I called this. That allows us to notice that what we're doing is we're taking this vector 3, okay, which is just holding on to 3 pieces of information. This is linear algebra, but you don't have to do the math. The game engine does the math for you. But we're saying I'm going to take this vector 3 and I want to rotate around that vector 3 the appropriate amount based on how long it's been since I last rotated. So if you were to slow your game way down to 1 frame a second or something like that, you would see little tiny twists, right? But if our game's running at 60 frames per second or 120 frames per second, it looks very smooth as they're spinning around. But that's effectively what's happening. We're just doing little tiny adjustments based on the amount of time that's passed since we last adjusted something. Make some sense? All right, so this would be something to kind of make sure you wrap your mind around. It's not a super hard concept, but if you need to know how much, if you have to have access to what has occurred or how much time has passed, which we apply to a lot of different things, that's how you do it. Go ahead.
Basically, like with time dot time, it's very similar to like claymation in the way that it's each picture that you play dummy or whatnot, and each frame the updated is like a new sort of like make it smooth.
Yeah. So for online people, the question was, is this time delta time kind of like claymation stuff where you put the little figure in different poses and it happens every so often? I mean, I would say it's definitely related to that, but it's kind of the combination of that with the update method, where we're, claymation probably has things happening much less often than 60 times a second, right? But similar type things where you don't do too big of a move in a single frame. Because imagine if we were rotating our entire things without applying the delta time, which is going to be a fraction of one, right? Probably, point if we're doing 60 frames a second, right? That means 1/60th. This is going to get called every 1/60th of a second. That's a small number. So the amount we're rotating is tiny. If we took the delta time out, we're going to see large chunk moves, right? Depending on the frames per second we're working with. So it's not going to look very smooth to us because it's moving humongous amounts each time. Because ultimately it would be ×1. So it would pretend like this is across 1 second. That would be it'll rotate 60 times more more in a single ninja move than it would if we do little tiny rotates here. All right. But I think you accurately described it, that this whole little combo move here, the idea of updating everything, but also having the ability to minimize how much you do of something based on the amount of time since you last did it, is very much that claymation. How often do I want to change my poses? That type of thing. All right. So again, every one of these pickups have a rotator script. So we have 8 of these running at once. Each of those 8s will have their update function called every single frame, because update calls once per frame, not on any sort of fixed amount. And this is what happens. We're going to rotate it a little bit based on how long it's been since the last time we rotated. Now, one thing that's taken out of our hands that we can't necessarily worry about, and it's related to something we've already talked about, is just because I have 8 different pickups. So 8 instances of that game object, which each have this script running on that game object. So presumably we have 8 instances of this script. How the game engine actually handles this under the hood might be different than that. It might kind of have like a single update queue where all the stuff that should be occurring gets thrown into this queue. So rather than it having to go into 50 different places to hit all these different scripts, the scripts kind of report their update stuff to a central unit, which just feeds off of that and goes or multi-threads that and tries to handle those things separately across your multiple threads to get a smoother final product. That's kind of the idea of a game engine. It does the heavy lifting behind the scenes for you so you don't have to worry about it. As programmers, we get to subdivide it. We're having things kind of compartmentalize as attached to the objects that we want it to deal with. But how it happens behind the scenes doesn't really matter to us as long as our what we want to happen happens. All right. So this is a simple little script that we're attaching to every one of those game objects, and it just makes that guy spin around. All right. So that's rotator. Let's see. We were talking about our collision enter, so we can do certain things when things physically hit each other, not being a trigger. We can choose to programmatically intervene if we want to. We don't have to do this if we don't want. We can just let the game engine say these things smash into each other and they're going to bounce wherever they're going to bounce. All right, so that's kind of the beauty of the game engine, is we can just have game objects out there with rigid bodies hanging off of them, and it handles all of it for us. But we do have the option of interjecting some logic into normal collisions. Whereas a trigger, I suppose we don't have to write the code to enter the trigger. It would just be a waste of time then that you even have a trigger on a collider on that guy, because nothing's handling it. Being a trigger, the game engine's not going to do anything automatically. And if you don't write any code for that, you're wasting a component is the idea there. All right. Any questions on the differences between a trigger-based collision and a non-trigger-based collision? One's not better or worse than the other. It kind of is up to the programmer as to what's the best solution for what you're trying to do. if you go back to old school games like Super Mario Brothers, for example, there wasn't a whole lot of randomness in a game like that. So these were platformers, and you could predict when there was going to be one of the turtle guys on your screen and that kind of stuff. And what those games did is, in many cases, platformers, they would have triggers set up where once Mario passed a trigger, it would then cue certain things up ahead to start moving. Right. And once you pass those, let's say you didn't kill off the turtle, right? You just jumped over him and kept going. Once you hit the next trigger, he would stop moving. That way you're not using system resources for something you're not seeing. Right. Now, on top of that, though, game engines also try to be intelligent where they're already trying not to throw a lot of processing power at things you don't see. Okay, so it's trying to do a lot of that heavy lifting for you, but imagine back then, similar to how we talked about like the primitive types in C++ and Java, that was a different time. Computers were not nearly as powerful and things like that. So we did need to be a little careful about how much stuff we were asking the processor and kind of the pre-GPU GPUs to do, because it really could bog down the game. All right. So let's see here. All right, so let's look at our camera controller, see what this guy does. All right, so camera controller, and who is this hanging off of? Is it hanging off our main camera? Yeah. So your scene came with a main camera, and that main camera we added a script to called the camera controller. Going back in here, notice that inside of camera controller, we have a public game object called player. What does it mean to make this game object public? What are we accomplishing there? Remind me what MVC is. Go ahead.
The accessible and the
Editor thingy.
editor.
Editor thingy bob. Right? Okay, so MVC, model view controller, says it's a good idea to keep your user interface separate from your logic, separate from your data. So in this case, why is it giving me all this junk? In this case, one of the things we want our camera controller to do, if you look down at late update, which is just, it happens at the very end, we kind of force when in the update queue this occurs. So we're saying this is kind of a low priority update, but we still want it to happen as often as possible. What we're doing here is you're making the camera chase the player. That's effectively what's happening here. That way, as the player's moving around, the camera's shoulder surfing around him and stuff like that. You can actually accomplish this without a script. I'll talk about that here. Well, let's just say it now. So right now, what we've done is we have exposed this player game object. That way I can programmatically talk about a game object that's on the scene. We've exposed that to the Unity editor so that when I click on main camera and I go and look at our camera controller script here, we see that it expected me to connect our player game object. So initially, can I get rid of that guy there? Initially, it would have looked like this, none game object. It's expecting me. We've exposed that variable to our editor, and it wants to say connect up the game object that you want to have connected to that variable. So that's where we go and just drag our player over there. So now we've taken a physical thing in our scene and connected it to a variable on the code. That's MVC in action. And then what did we do with that? Well, initially inside of start, we set an offset. Single variable, it's a vector3. What is this guy doing? It's just positioning where we want the camera relative to the player. All right, and it's kind of sitting there behind the player at whatever distance we decide is the correct different distance. And then in late update, as long as we've actually attached a player to the camera, as long as we did that little drag thing to hook up our player game object to this variable, we're just having our camera move along relative to the position of our player. All right, so we decided to do that with a script. Now, another thing we could have done, and I think that the tutorial might have referenced this, is we could have, let's say, forgotten about the script for a second. So let's go into, let me just make sure my game is currently running. Yeah, because I've been changing some stuff. Let's see, expected. Player controller 3719. Oh, some of these things aren't saved. Should be fixed now. Another tip, when you make changes in your code, make sure you save them, because if you haven't, Unity's not going to notice the latest, greatest version of that. All right, so and I lost way quicker there, but game runs right now. So let's just pretend like we decide we want to handle our camera dragging behind our player a little different. All right, so I'm gonna go to my camera. I'm gonna get rid of that. I'm gonna just disable the camera controller. Hit the little checkbox next to it. So the camera no longer has that script doing its bidding. Let's go ahead and run it again and see what happens. All right, so we see it's no longer moving along with the player, so the player can kind of zip off the screen and that kind of stuff. Game still works. So we might say, well, since I want my camera to kind of relate to wherever the player is, what I'm going to do is I'm going to drag my camera to be a child of the player. Just structurally. It may have referenced it. I don't remember if it had you do it or not, or had to do with the script. Yeah, so let's talk about that. So we're just going to go ahead and run this. All right, so why is it doing that, do you think? Go ahead. Basically true. When we use our inputs, our player is a sphere, and our inputs say push on the rigid body of our player, which makes the player roll, right? So when the player is rolling, that means if the camera is attached to him, pretend like the camera is connected to your the bowling ball that is our player by a stick. As you roll it, that stick is going to roll right on with it, right? So it's forcing that type of thing. So by not doing this with a script and just saying, oh, well, I want my camera to be this relative position to the player, I'll just make it a subcomponent of the player. So now his vector 3 position changes automatically relative to his parent's vector 3 position. Otherwise, all of these things, the parent is the world, the scene that is not moving, right? The scene doesn't have their coordinate system change. So if I go to player here and we look at, let's see, is it in rigid body? Yeah. So if we go to our rigid body in our player, which is the thing that we're using to, to make our player move, we shove it, right? If we look at our player script, here's our player controller, and on move, we're setting a vector for kind of the angle at which we are trying to move, and then we add force to that rigid body at 60 frames a second, 60 times a second. All right, so we're just pushing it. And the natural inclination, if you have a bowling ball sitting on the floor and you push it, is it starts rolling, right? Well, so one thing we can do is if we really want to avoid this script, we can go in here and we can say, oh, well, I want to fix the rotation of my bowling ball here. So I'm on my player game object. I'm in the rigid body component of it. And I can say, you know what? I don't want this guy to roll at all. So I am freezing his rotation. We're not changing the fact that we're shoving on it, okay, but we are freezing its rotation. So now you see that our camera follows much, I don't know, much better. You could probably make the, oh, that's actually funny. Why did we get this error?
That's what's- and then it stops.
Well, we lost, right?
Yeah.
You lose. What happens when we lose? Deletes the game object, so it deletes the player. And what's hanging underneath the player hierarchy right now? The camera. So when you delete a game object, you delete everything that's underneath that game object as well. So we lost our camera. So we have no way of seeing our game anymore. So it's yelling at us and saying, hey, there's no cameras. You just destroyed it. All right. So punchline is don't lose. If you want to keep your camera in this example. But the important piece here is just to kind of understand this is a trade-off in programming. In our case here, when we needed the camera to follow the player, we could have had a script and left the camera secondary to it. And most of the time that's fine unless the player loses. But otherwise, we can just use the hierarchy thing and have it auto follow and put some constraints on our rigid body so it doesn't have the camera orbiting the player. Go ahead. Well, you don't have, I mean, no, because the camera, you would only add a rigid body to the camera if you wanted things to be able to smash into the camera and feel it. In this case, we're just asking ourselves, how do we move players? So our player game object here has a rigid body, and the way we make our player move is by adding a force to that rigid body. Oh, that had to do with the player's rigid body. When I click on player here, I go to its rigid body. I click on the constraints dropdown or constraints folder flippy thing, and I just put a check mark next to X, Y, and Z for freeze rotation. You're just saying, don't rotate. Game object, you're not allowed to rotate. I don't care what kind of force hits you that would have otherwise made you rotate. You don't get to do that. So effectively, the way this is working right now is when we're adding force, we're kind of like almost like sliding it across the ice, right? It's not picking up momentum itself. It's just kind of, we have to hit it hard enough. So it starts sliding. So these are kind of the decision-making processes you might go through as a game developer doing these things. There's not a right or wrong necessarily. So a lot of times what you'll do when you're working on your games is you might say, okay, well, I think the way I want to accomplish this is this way. And then you go and test it and you realize, in this particular case, why is my camera spinning around like crazy? Well, what can you do about it? Well, we can limit the rotation. Well, is that what we want? Maybe whatever game you're working on, the rotation is important. Maybe it's some kind of shooter where the current orientation of the player is important for the direction that he might be shooting, right? If the projectiles always come out of the front of the player and he no longer can rotate, it doesn't matter which direction he's trying to shoot, he's always going to shoot this way. You might decide rotation is not something I want to get rid of, something along those lines. So sometimes it's a matter of playing with it, see what result you get, try to understand why you're getting a wacky result in the event that you do, and then decide, well, is it in my best interest to fix that given my current solution, or do I back up and try a different approach? Again, considering that if I have 500 game objects in the scene and each one of them has multiple scripts associated with it, which you can have 10 scripts attached to a single game object if you want. What kind of burden is that putting on the running game? chances are we're not going to run into significant burdens in the things we're doing in here. But if you were working on a large game, this decision making becomes important. Okay, so I'll go ahead and I'm going to move my camera back out from inside of player. I'll go ahead and go to player. I'll turn the script back on. Oh, sorry. Oh, it's not the player script. It is the camera script, right? I'll turn the camera script back on, which knows to follow this player game object. But remember, my player, I still have his rigid body set to not rotate. It's not a problem. If I run this, the camera's going to follow it as the script tells it to follow it. Just our player's marble here isn't actually rotating. It's just sliding across the ground. You probably will notice that the player stops moving a little quicker. Kind of almost seems like there's a, you're as you're pushing it across the ground, there's a surface, tension as they're bumping into each other, friction that's slowing it down. So if you go into player and you turn those things off, we may or may not be able to notice that it rolls a little smoother in this case. Yeah, I just let go of it. It's still rolling. So we see a pretty substantial difference in behavior. So you get to decide what makes the most sense for your game. Another tip, something that I'm sure maybe some of you ran into as you were trying to get your game working. Sometimes while your game is currently running, so in this case, my game is running, we see, you also will find that you make your game too hard for you to play it. Just turn your collider off. So we see this is happening here. While the game is still running, I can go into player and I can set his rotations to freeze. And then I can start doing it again. You see, it's no longer rotating. So maybe you have the behavior you want now. So you can mess with it while the game is actively running. But when you stop the game, any things you set get unset. So sometimes if you have like a position or something that you're happy with while the game is running, so let's say you're kind of setting your camera at a certain level. I see we have 1 minute. That's fine. You might come up here and say, okay, I got my camera right where I want it because you can move it around while the game is running. You can then come up here to transform and say copy. You can say copy an individual aspect of that, either position, rotation, or scale or component, the whole component. That way, when you stop the game, you can go and paste your final values back in because they will get unwritten. That makes sense? Common issue is forgetting to switch stuff back. As you might imagine, you're going to see me do that relatively often. And I'm obviously doing it for educational purposes. I'm always doing it on purpose whenever something goes wrong. So you can learn from those mistakes. All right. So we'll stop there. Where we're going next, in case you want to play with this, what I would be having as our next assignment, but I don't want to throw you into the deep end with the sharks, is we're going to be moving our dungeon. We'll probably start a new game. And we're going to be building a single room with walls and a base and stuff like that here that will have 4 exits, potentially. What we want to then have is a script that can turn 1, 2, 3 exits off. So they disappear because they're no longer valid exits. That way our game can have a single visual room that we just keep changing that room's offerings based on the available exits for the underlying code, the room the player's currently in. So we're going to be connecting our behind the scenes code to what our visual thing says. So whatever our code says is the current room we're in, the room we see will match that. So that's where we're going with this. You probably have about 90% of the stuff you're going to need to accomplish that. But I'm going to give you kind of a starting point. All right, so I'm gonna shut up. We have a couple of questions. I'll keep the recording going while I answer them, but everybody we do not meet Friday, right? Friday is some vacation day. That's why I didn't give you so next time I'll see you is on Monday. So be safe with the snow if you're driving, all that stuff. What's up?
Making the dungeon crawler like 3D, the mix like 3D, 2D that we have here, or are we making it like straight up a 2D looking down?
Well, I'm probably going to do it so the question for those of you online is what's our plan for the dungeon crawler? What style game is it going to be? I'll probably have it be this 3D type of look like we have here. But the player, I won't have us go from room to room to room to room, physical rooms. So if our dungeon has 6 rooms in it, we won't have, not that we couldn't, but we won't have 6 different rooms initially. We'll have one room that we change the properties of, doors appearing, disappearing, whatever. So as a player, so if I hit the left arrow and the player starts going to the west, when he hits that west room, the room would then turn back into the room that was to the west, and we'd see the player roll in from the east. So we'll kind of see it that way. Similar to like how Legend of Zelda works. If you think about that. Then we could, as a secondary thing, we have to kind of play around with whatever time we have and stuff, is if you wanted to, you could instead build 6 physical rooms. So now you don't actually have to handle the logic of your your room having doors disappear and appear and things like that. Instead, you would just physically make your dungeon, and under the hood, you're keeping track of where your player is and things like that if that was important to you. But otherwise, you can just drive your player through the dungeon because it is a physical dungeon with rooms that lead to other rooms. Kind of is up to you. That will take more resources because now you're storing more stuff visually on there. It's also how games that do, because you're obviously a gamer, when games say they procedurally generate stuff, they can take one of our prefabs here and then procedurally randomly create exits in different directions and create instances of those prefabs, adding them to the scene. So you don't have to physically drag them in there. You can programmatically create a random map, that kind of stuff. Sound good? All right. If there's any questions online. Yep, you take care.